Good afternoon, everybody. Welcome to our PublicPower X webinar hosted by Verizon, Best Practices for Deploying Smart Infrastructure. If you're having trouble hearing the audio or experiencing technical difficulties, you can contact us at educationinfo@publicpower.org, and we'll be happy to assist. We've muted the phone lines to reduce background noise, but we have time for some Q&A at the end. So if you have a question you'd like to ask the presenters, please use the chat feature at the bottom of your screen during the webinar for anything you'd like me to pose to them at the end of the presentation. After the webinar in the next couple of days, we will send you a link to the webinar recording as well as a copy of the presentation slides. Our speakers for today are David St. John, Kevin Gowans, and Greg Myers. Kevin has 20 years in public power service. He holds an MBA with emphasis in management and communications and a BS in organizational management. He has served in many roles at Athens, including apprentice lineman, journeyman lineman, assistant crew foreman, line crew foreman, and director of public power systems operations. He was named successor to David St. John as superintendent of the power division at AUB when David left to join Empirical. David St. John has 28 years of experience as an electrical engineer in public power, including 18 years as a consultant, and the last 10 years in leadership positions with the Athens Utilities Board of Athens in Tennessee. His experience spans a broad range of power system challenges, including today's topic of discussion. David recently returned to consulting with Empirical of Covington, Louisiana. And Greg has been a leader and innovator in the smart energy and water industries for over 20 years. He has been involved in the product management, marketing, and engineering of new solutions, resulting in over 60 million deployed AMI endpoints. Greg is the product leader for Verizon Wireless's IoT LTE-based GridWide AMI solution. He received his BSEE at West Virginia Tech and his MBA from Johns Hopkins University. And with that, I'll turn it over to Kevin and David for a case study from Athens Utilities Board.
Good afternoon. She said, I'm Kevin Gowans, the Superintendent of Power at Athens Utilities Board. We're just going to walk you through a little bit of how we landed with Verizon as we're looking for a couple of solutions. So I'm going to give you an idea of kind of who we are and what area we're in so you can see how this solution has impacted us. So we've got about 550 miles of 12 kV distribution line and about 16 miles of 69 kV sub-transmission. This kind of outlines our system here, this map that you can see. We have 6 substations. We have 5 listed here, and then we have one that's a transmission substation. We feed 69 kV to a large customer, and it's over in this lower part of our system here. We've got about 13,000, somewhere between 13,000 and 14,000 power meters, and our peak load is 120 megawatts. We service everything from large industrial to small residential. We kind of got a mix. We serve 3 cities, so while we're a municipal utility, a lot of times that looks more like a single city. We're kind of set up much like a co-op. We have 3 cities and all the rural area around them. So we cover a broad range of different obstacles when it comes to some of the smart system releases. We at this point have no full existing AMI, and that's kind of where we wound up. We had a program we wanted to run, and we didn't have AMI meters. So that's where David kind of had to take on a challenge. Just to kind of give you a context of where we are, I've outlined the eastern part of Tennessee in red. We are in this very lower corner, and you can see we're right along the foothills of the Great Smoky Mountains. So while part of our system, we're what's classified as the Tennessee Valley. So the plateau, Nashville, all that area is over here to our left. Then it falls off into the Tennessee Valley and then starts back up onto the mountains here. We're in kind of a bowl in the southeastern part of Tennessee. To give you an idea of what our terrain looks like, it's gorgeous scenery here, but it really can cause some problems when we're talking about different kinds of deployments. You know, you think about penetrating fiber deep into these mountains. That can be difficult. Mesh systems and radio systems, mountains cause a whole lot of problem. And being as widespread as we are, having the mountains included, that really kind of causes us some real issues, excuse me, when it comes to serving the outer limits of our system. So to tell the rest of the story, David came into this challenge, and he really handled, I followed on his heels, and he really handled all the deployment of this. So we'll let him explain how all this really came to be.
Well, it's interesting to work with a utility that's not quite big, not quite small, but we do pursue as many advantages, just like I'm sure the rest of you do, as anybody else. And in 2017, we went through a series of different project evaluations, and one that stuck out as we thought would be valuable to pursue was conservation voltage reduction at CVR. Now, I know that goes by a number of different names, and I'll just call it CVR for the sake of this production. But it suggested that we could avoid 200,000 or more a year in demand charges, and that's just taking into consideration that we could control 3.5% of our total available load. So we do have a fair chunk of, let's say 60% is pretty predictable for us as being an industrial kind of a base. So it makes a nice platform, but that does mean that there's less available for the actual reductions potential from reducing the voltage at the substations. So we went through the marketplace and tried the different solutions, and the OATI came out as the provider of choice for us. So OATI's proposal was an all-inclusive. They would provide the whole soup to nuts solution for us, and the total cost was about $280,000. However, we had some other project needs, and as you can see, one of our biggest sore points was a working SCADA system, as well as since we didn't have bellwether, we didn't have AMI, so we didn't have the bellwether meters out in the field. Instead of rolling all of this under OATI, we decided we bust this up, or I decided we bust this up into 3 different projects running simultaneous. But one of the things we would take advantage of is the same time this project kicked off, Athens was already talking to Verizon about replacing some 2G cellular remote disconnect meters. Now that's for the purposes of turning people on and off that don't pay their bill on a regular basis. So avoid those truck rolls. And this turned out to be great timing for us to take advantage of that. Now, why that's important, some of the advantages that we found in the process of that search was this wasn't going to be a full-fledged deployment of AMI. And there was not an appetite or back-end processes that could consume that information. So it was an advantage to us to have somebody else own or provide the infrastructure. We didn't have servers, software, systems to support in the process of talking to these meters. So Verizon was very attractive for that purpose. All of those purposes that we also estimated they were going to be able to help us with the CVR implementation. So I piggybacked purchase of some meters for that purpose on their system. So this is how the final solution turned out. We went into our substations and revamped all of our equipment to respond appropriately to some SCADA signals. You can see inside the substations, we typically have single phase voltage regulators on each feeder. So we had very granular control, but those regulators and the controllers needed to be set up to provide a meaningful path of communications back upstream to our headquarters. Now, over the course of time, things like fiber had already installed. We basically were able to replace the brains at the beginning of the substations, program them appropriately, as well as all the downline equipment. And that provided, as a whole, our usable working SCADA system. So on top of that, we added OATI, and we created a DNP stream between us and them to provide the information from our system, as well as to be able to receive commands from them, traveling down this path all the way down to the regulators to make voltage controls. We decided in this project to limit our voltage control to just what was inside the substation. We didn't have to deploy additional equipment, additional resources, nothing in the customer's facilities. This is purely taking advantage, leveraging what we had available without extensive new programs and procedures. So out in the field, we added 120 Verizon equipped 2S residential meters and attached all of the particular GIS information to those meters in the Verizon system. And then we paid Verizon to write a piece of code that would provide a multi-speak path to OATI and provide the 5-minute, a 5-minute rolling average of voltage from this set of meters upstream to OATI. So OATI could then make appropriate actions of what to do during a voltage event. So this is a screen capture of how we set up our SCADA with the regulators, individual regulators. You can see that we have set points that we could change. The center band of 124 volts is typical with a bandwidth of 2. So it allows us to range up to 126 or down to 122. And then we can lower this voltage. This center band voltage is how we would manipulate the voltage lowering from OATI. We'd send new commands to progressively lower the voltage until we got the feedback from the field. So that's the interaction between OATI essentially and the SCADA system and our substations. This also gave us an interface to be able to do a check on what's actually where the settings is. If OATI sends a command, could we look here to find out, yes, it is what it's supposed to be. No, it got hung up because the regulator control had lost its mind, whatever the case may be, helped us to debug the pieces. So separate, in addition to this, we had deployed these Verizon GridWide meters out to our field. And you can see this is a representative sample across of our system that does a pretty good job of blanketing the system. So just from this, even though this is only 3% of our meters, 300 meters out of 13,000, we still have a pretty good picture of where is energy consistent. Do we have problems in a particular area? It gives us a lot of different checkpoints for a number of things that could be happening across the system. Notice over to the right that you can zoom in from the map view if you care to pick out a particular meter and examine it for more information. Now, the real question was, all right, I've got these meters in the field. How am I going to report back up the voltage? So what OATI says, we need the voltage on average, what happened in the last 5 minutes at any particular meter. So we were using multi-speak as command path. Well, we found that sending the exact voltage number at a meter was not available as one of the multi-speak commands from Verizon. However, we did find this tool that allowed us to figure out what range is this meter in. So I divided up the spectrum of voltages into everything from a high voltage on a 120 volt basis down to low voltage. Now you'll notice the meters themselves work off of a 240 volt basis. It looks like a mistranslation, but it's just to put it into terminology that's more commonly thought of as far as the way we think. So over here, I've got band IDs that range from 1 to 6 that kind of divide up everything from very low voltage to high voltage. And over on the right-hand side, if I'm looking at the graphs that are produced in the GridWide system, I can tell if it's green that it's in an acceptable range. If it's yellow, it's getting pretty low, it's getting close. And if it's red, I've got problems. Or if it's black, I've got problems. So this helped us define how we were going to determine where these meters were. So those ranges translated into a policy here that I've got, you can see the band IDs, and we deployed those into 118 available meters that we have for this project. So every 5 minutes, this policy that's running in the background is reporting on what happens on these line items. For example, at this particular meter, a snapshot over the course of time shows at these particular times, this meter crossed a threshold from 5 to 4. So it suggested it crossed from a threshold of somewhere in the range of 122 to 126 into 118 to 122. So 122 became a tripwire that then sets off this event, and that event is sent upstream to OATI. So now I have some idea as I lower the voltage at the substation, just how well or not well are the voltages responding at the meters out in the field. So I could look at 2 or 3 systems. I got the SCADA system, this system with GridWide, as well as the OATI interface to be able to determine, is everything healthy? Is it running like it should? If there was a particular sore point, we could draw into it very quickly. So on the OATI side, they help us decide what's a good event. I don't get triggers from TVA to suggest I'm about to have a coincident peak with them and their system. Athens Utilities, being part of TVA, is an all requirements provider for us. So that means that we're just doing our best, and especially we'll try to target at least a couple of events, maybe at the beginning of the month, so we've got some kind of starting point. And as a month progresses, we try to pick out what's going to be the peak event. Is it whether it's cold or whether it's heat or some combination in some of these shoulder months. So we've loaded up our historical information of 2 years worth of data to initially just to get rolling with OATI to show historically on this day, what does our load look like? And this is looking at the load that's on the controllable circuits that were involved, as well as what's happening with temperature. And then we throw in the variables that are not well defined, like Memphis is a much bigger animal and Nashville and Huntsville are going to drive peaks. Athens is not. So we may decide, well, we're going to run a peak event this day, even though this wouldn't normally be our peak, but we're guessing this might be a TVA peak. So a combination of different events helps us understand what timing to have for an event. And then we can schedule it through OATI. And in the process, we choose what resources do you want to include. So for example, this shows a list of different feeders. Some feeders we exclusively keep out of the mix because they're largely industrial based and are not going to be good candidates for this type of event. Others are largely residential, and we'll keep them on unless there's some other event that's happening. Maybe there's maintenance or some other issue, switching that's abnormal, that maybe takes one of these resources out of play. So we can choose our events, and then then an event happens. So this is a look at what happens at looking from GridWide at one of these particular meters that was involved. And this shows voltage riding along through a normal range. And then on November 3rd of 2020, we scheduled an event in the morning. So definitely you can see this huge drop where we've changed the voltage, the set point voltage at the substation, the regulators. It rode through for some period of time, floating along at the bottom, and then the event ended and the voltage came back up to a normal range. This whole time, I can tell this in this particular meter, it stayed within a good range, acceptable range. We didn't have any violations. So if you combine all of that back at the substation, this is the view that you get out of OATI. I can see that the load, this is demand of our system growing over the course of the morning. And we expected, all right, well, there's going to be an event. So I called, scheduled for 7:15 to 10 o'clock to be a voltage reduction event. The voltage was reduced progressively as much as it could push into the system without causing violations with the feedback from the Verizon meters. So this light green line at the bottom represents what our actual flow is. The darker green line is what we would have been. There's not a magic hocus pocus to get the difference between those two. That's actually V equals IR, fairly simple and reliable to say, well, that really was a savings of this much power. So in this case, this event saved us 2,000 kW, 2 megawatts avoided energy or avoided demand. So at slightly over $10 a month for kW, that amounts to a $20,000 event. So this is the final purpose or the final direction that we were trying to aim by putting piecing these pieces of the puzzle together for a full financial benefit for the utility to be involved in this type of a production. It took us 18 months to nail down all of the details and prove them out of the 3 different systems working together. And it took us about 18 months to have the project pay for itself. So, and now at this point, we have a small bit of ongoing cost of either the meters or the OATI access and evaluations to keep this rolling. And it does effectively turn into avoided cost at the end of the day. So we've deemed this to be a very productive project. Now, outside of this, what initially kicked off the idea we wanted the Verizon meters was we needed a way to turn the meters on and off. This is a sample interface of commands that can be issued from the web interface. So on a normal basis, you can see I've highlighted the turn services off, turn them back on, depending on whether a customer has come in to pay or they're now on the cutoff list and have passed the time to pay. Another thing that happens is we're still reading by hand. So there's any number of fat finger problems that happen in the course of reading meters that now we've got to roll a truck to get a reread, and I'm sending a lineman out there to do that. So this reread is costing a lot of money. So now for the 300 odd meters that I have out there that are Verizon equipped, the guys can pull up the meter on their phone. Since this is all cloud-based and this is off of a web browser, they can actually get the reread right there. They don't need to roll the truck to get the information. And of course, you can see there's other information, but those are things that are happening every day. And that access, to not have it as a client or something that's pinned down to a particular location or particular computer, has been very helpful for us to put the tools in the right hands to get the jobs done. So there are other things that we have found as ancillary benefits out of having this AMI type information. And one is power quality investigations. We get calls from customers complaining about, hey, what's going on with my voltage? My lights are flickering. They're whatever the complaint is. Where we have these meters available, we're able to pull this up and take a look at what happens versus having to roll a truck and send a meter out there, put a special recording meter or monitor on the line just to find out if something happens in the future. This gives us an ongoing basis of what is happening out there historically. So for example, you can see these voltage dips. Even if I was just cruising through the meter population and I saw this, whoa, this looks a little odd. Everything is within this green range, which is acceptable, but these sure are some severe reactions to the voltage. So why? Well, if I overlay the current, I can see, well, I've got some big current spikes from the customer. So immediately I can evaluate uses if I'm talking to a customer to suggest, all right, you have some really big current spikes, more than the average coming out of your house or of a residence. This is all residential load. So 120 amps spikes suddenly might be the result of an HVAC motor having trouble or some other type of a customer load. But what it amounts to is it helps us narrow down the question. Is this a utility problem that I've got to fix, or is it a customer problem? And in this case, I'd suggest that it was probably related to the customer. We might do some more digging, but this immediately gives me some tools in my hand to answer those questions. So here you can see that the current and the voltage are not coupled closely together. You can see the voltage changes in green. And now I do like that this does show, for example, this voltage was climbing at the customer. It got to this point, it looked like barely see a little bit of black on my screen where it hit this high band. The voltage regulators dropped the voltage at the substation. Crawls along. Now I've got the point, I've got low voltage and I can see the regulator raising the voltage. Again, it's raising the voltage. So it's very revealing to see from point to point on a system how strong the system is, if it's acting properly. It's really been insightful when you have time to stop and deal with it. That's usually the trouble I'm sure that all of you folks have as well, is how do you make enough time of the day to be able to pursue these kinds of questions? But they do at least come up on their own in the course of time. So another thing that shows up is power blinks. This report is convenient. I've had plenty of calls from customers to say, my lights are going out every day this week at 2 p.m. and I'm sick of it. Now, what are you going to do about it? Well, how do we know? What's really happening out there? And this gives some insights into, is it really happening? Do we see the same thing? Or is there, is it on some other schedule? Anyway, another convenient way of helping answer customer questions and power quality problems to provide good service for our customers. So that's just a quick clip of some of the details that it took to put this together and how we tried to be creative and leverage these investments in different systems to answer some questions for ourselves, as well as save some money and not just have a doodad that sits on the side that nobody really pays attention to. I'm sure there might be some questions that are prompted, as well as ideas that you'd like to share with us. It's wonderful being a part of the Public Power to the sharing of information and being able to avoid problems, pitfalls from sharing information with each other, or gain advantages from each other because we've recognized advantages as well. So beyond this, there are a lot of other things that the Verizon's GridWide system does. They've developed, we focused specifically for what we needed on the power meters, but they have a world of other implementations that they've been growing. And Greg Myers is here to tell us more about that. And I'll stop sharing my screen so that he can take on from here.
David, this is Pam. We actually got a question that we thought we would go ahead and pose to you real fast before Greg got started. So I guess it's kind of a two-part question. The first is, are all the regulators based at the substations, or are they distributed across the system? And then I think it's the second part. Are there also one set per feeder, or are multiple feeders regulated by a set at the sub? If controlled units are all at subs, are there any units out in the field that aren't tied in working against CVR? So
I certainly understand. We had a couple of LTC units or one bus regulated station, but most of it is feeder regulated for Athens. So each feeder had its own set of individual phase regulators. We do have some out in the field, and that was part of the progress. Is we like to take All right, I saw it that I went on mute. I'm sorry. You want me to go ahead and answer that one?
Yes. Sorry, I don't know what happened, but somehow you got muted, so we just missed about 10 seconds of what you were saying.
Okay, well, I'll make it quick. Our system is largely feeder regulated, so there are some regulators downstream that we're hope to move into the field. I tell you, one of the things I learned out of this is we were actually able to deploy some capacitors in the right places and take regulators out of the field. That was a great savings for us. There are some regulated areas that we'd like to add to this system, and they are outside of the substation. So those are available as to be deployed into assets, but they are not currently being used for the savings that we're using. I think that covers most of what the question was related to.
Okay, great. So now we can switch over to Greg when he's ready. And if we get any additional questions, then we'll just cover those when Greg is finished.
Greg, we don't hear you.
There, can you guys hear me now?
Yes.
Yeah, we got you now.
Okay, sorry about that. It was pilot error. There we go. And I'm not sure if you can see me. I had some problems trying to get the camera turned on. So thank you so much. It was a great presentation, David and Kevin. I wanted to go through today and talk a little bit more about not only GridWide, but a little bit more about what the industry is and where the industry is as far as next steps. So from an AMI growth perspective, you can see that we have been in this up through 2021. There has been amazing growth for AMI. There are still some utilities that haven't deployed, and there are some utilities that are now starting into their next phase of deployment. And you can see that that's going to become a big growth area for AMI over the next few years to dramatically increase the number of AMI meters out there and shipments that the different vendors will have. It's gone, what's been driving this, so the Smart Grid 1.0 was developed in order to provide more communication to not only to the utility, but also for the customer, and to be able to do TOU demand, really kind of a commercial grade type of meter on those homes reporting back, and then the introduction of remote disconnect and home area network and so forth. Smart Grid 2.0 brings a whole bunch of new challenges to the market, given that we're migrating from a one-way delivery system from generation to transmission to distribution to more of a circular or neural grid type of application where you have inputs coming from distributed energy resources like solar and wind and those kind of things, and you have both at the commercial and the residential level, and a lot of states are pushing for you to be able to enable privatized generation and storage for those. And the problems it brings for the utility is no longer are they managing all their equipment has been developed to manage a one-way delivery system. Now you're going to have power coming from a lot of different points, and to be able to control the quality of that power to those customers in the same fashion that they did before, they're going to need a lot more devices on the grid to be able to provide them with monitoring and control to maintain that type of capability. And looking at the system migration versus replacement. So if you have a Smart Grid 1.0 system, then you have you've already gone through a lot of these steps. If you haven't, there's a lot that has been done because of Smart Grid 1.0 and the push for that for utilities that make that a much easier journey for you. With Smart Grid 1.0 drove API development and support so that you would have common interfaces between applications, making it much easier for you to be able to integrate and deploy. Metering and communications standards were established, drove a lot of the new standards in metering. Meter data management systems became in vogue as far as utilities utilizing them because of the amount of data that they were now getting and being able to manage that data. Multi-vendor integrations used to be that if you bought a technology from a meter manufacturer, you were pretty much tied to that technology and to that meter. Smart Grid 1.0 moved that to the ability for and drove these vendors to have to provide their communications on multi-meters for the utilities to have freedom of choice. And then there were a lot of building systems and CIS upgrades that went on through that period of time. Smart Grid 2.0 will take advantage of all of those things and will add in grid and self-healing restoration, enable you to automatically digitally control the grid at different points, two-way communication for large quantities of the distribution devices, in all building a more reliable network that you can help manage both centralized, but also push some of that management out to the grid with grid edge computing and control. We think that it's important that all of this is built on an IoT-based platform so that you're no longer tied to a proprietary type platform for you to expand on your system as you move forward beyond Smart Grid 2.0. So tactical deployments, that was some great examples that David and Kevin had provided with conservation voltage reduction. the systems, Cellular provides the ability for you to be able to go out and do these tactical deployments. And here's a list of several of those types of capabilities that you would have to be able to go out and take advantage and get your return on investment. I thought 18 months was a great ROI that they mentioned, but being able to do interval data and complex billing and analysis, TOU and demand, net metering for solar support. I'm sure a lot of you are getting a lot of solar installations in your area, and how you're going to manage those and rate structures and so forth. Outage and restoration, and then prepayments starting to be on the rise around the country as it's no longer looked at as going after just the poor payment accounts, but also providing folks on fixed incomes with the ability to be able to better monitor and pay for their utility bills. Interval line voltage monitoring to monitor sags and swells, power quality. Some folks are utilizing it for going away from the one-way paging demand response into a two-way type of demand response for air conditioners and hot water heaters, theft detection. And then I'll talk a little bit more about this next one on the following slide, but street lighting control and billing. So that's been an added function and capability of being able to of deploying an AMI system, is that you also go outside of just the typical distribution and metering type of capabilities into things like street lighting control, which is really the first IoT application for smart cities. So looking at our LightSense node, full-featured lighting control capabilities, you have the same, just like with GridWide, you have the cellular connectivity that enables you to be able to install without having any special tools or anything. You have utilize the 4G LTE Cat M1 technology. It does the auto commissioning and GPS so that you don't have to have specialized folks go out there and do that deployment. The NEMA sockets have made it's built right into the NEMA socket, making it very easy to install. You have a lot of control over it through the photos. You have both the photocell and the ability to be able to do 0 to 10 volt auto dimming. So there's a lot of applications around both safety that go into that, and there's some college campuses that use it for disaster type of situations. Measures and reports power usage. So that's an added feature to be able to actually measure and monitor and bill for those endpoints instead of a flat rate. And then the LightSense node, it connects the network. It uses a authentication and encryption of each of those devices. So you have it's a secure connection for the utility, so they don't have to worry about any kind of security issues coming up and losing control of the lights. I talked a little bit about solar and EV chargers being some of the disruptive things. Solar is still ways to go, even though it's proliferating very quickly. Standards are still being established, but they're starting to get there with settling in on what they're going to do. As I talked about with the NeuroGrid, the ability to be able to control those voltage fluctuations that they get with weather is very important for maintaining the power quality for the customers. And then metering billing for solar becomes a challenge. EV chargers are going to bring that same kind of challenge, maybe to a different level, where now you have a lot of these things popping up all over the place that you're going to have to figure out how to support in your area. If you're in the state of California, you have some mandates that are going to drive electrification of transportation in the coming years. You have to decide what level you're going to participate in. And if you look at this chart, it talks about there's going to be 9.6 million charge ports needed by 2030. And the gray part is really what's going to be on the backs of the utilities. This is going to be the home level charging station. So 7,500,000 of those ports are going to be at the home, and the utility is going to have the ability to be able to manage manage those devices coming on and off of the grid and turning on and so forth, and size your assets accordingly. Naas, GridWide is a Naas application, as is our lighting application. It provides you a methodology of being able to fast and economically deploy for different use cases that you have, or if you're doing a full AMI deployment. It requires limited IT integration, again, going back to all of the standards-based APIs that you have nowadays. It's also securely hosted and managed by the for the utility, and with the utility having a utility-facing application to be able to do all of the things that they could do if it was an on-site type of application. It enables those tactical deployments I spoke about earlier, where the applications provide immediate benefits and immediate return on investment. The CVR is a great example of where you would deploy it for bellwether locations and get out of 13,000 meters with 130 meters, with 300 meters, be able to provide the system capabilities for conservation voltage reduction for the entire network. Makes it very easy to expand, and there's no dependence on full deployment for operation of network like in AMI 1.0. There were a lot of mesh systems that required meters to talk to other meters and so forth in order to actually build out the network. With utilizing cellular, you don't have that same issue. Every endpoint communicates independent of each other. And then the application, device, firmware, software upgrades, so all of that's taken care of for you. You have, whether it's security upgrades that you need to make, or firmware for the meters, or for the communications modules, or new applications that you want to deploy on those modules. Everything is managed through the system for you whenever that you're ready to make those changes. I wanted to provide an offering that we have both for lighting and for GridWide, for being able to go out and do a trial and get a flavor of both what utilizing this type of network and Naas offering will provide you to be able to go out and test out some of these different use cases. What we provide for electric utilities is a cellular enabled metering device. We provide up to 3 devices. They're 4G, LTE, Cat M1 communication services over Verizon's private IP network. You get access to the GridWide hosted platform for monitoring and managing devices. We do all of the setup for you for that. And then technical support and training throughout the trial for you, both at the beginning and throughout the trial. And then the cost is hardware and Verizon services are free of charge to the utility. You are responsible for participating in doing the installation and activation of the devices in a timely manner, and participation in the training that we provide, and then execution of a trial agreement, so that we flesh out what we're going to do and what you're going to do, and what the scope is of the trial that we're doing. And then we'll do a weekly trial review with you to see how things are going, and where you might need more help or some input that you have for us on how we can support you better. The use cases we support are the ability to read meters remotely, perform over-the-air meter programming, perform on-demand meter reads, be able to do remote service disconnect and reconnect, power quality measurements, be able to see outage and restoration events and assess those types of notifications and how valuable they might be, and then tamper events and other continuous metering type of alerts. For lighting, you very similar. You would get up to 12 devices, nodes to be able to go out and deploy using 4G, LTE, and then be able to access the lighting. We have a application for you to be able to go out there, just like GridWide, and be able to monitor and manage those lights accordingly. And then we provide the technical support and training during the trial. It also would be up to 90 days from the execution of the trial agreement. Cost is free of charge for the utility, And your responsibilities are the same as I had mentioned for the GridWide trial. Just looking for your participation and in executing a successful trial. The use cases supported for lighting are the ability to remotely configure and set dimming on off schedule for lighting nodes, monitor lighting status, and you get an online dashboard to be able to do that, review energy consumption data, be able to set up alerts for various conditions, and then asset management capabilities. So there's a slew of things that you have to do today if you have lights that you have to manage, as far as being able to service those lights and see what's working and what's not working, and providing a great level of service to your constituents. And that concludes my my presentation. We have the contact information here. Feel free to contact myself or Kevin or David if you have any follow-on questions. And with that, Pam, do we have some questions?
Yes. Thank you so much, gentlemen, for that really informative presentation. We're going to launch a quick poll here for our attendees. If you're interested in opting in and participating into Verizon's GridWide trial that Greg just mentioned, or if you're interested in obtaining more information on how the GridWide solution can help your organization to reduce cost and improve operational efficiency, please opt in by answering yes when the polling question is launched, and then we will share your email address with Verizon so that they can be in touch with you. And we do have, we will launch that poll in a minute. And I do see, while we're going to do that, we do have some questions that have come to me. If anybody else has questions, please go ahead and put them in the chat box. And I will also pause them to the presenters, I'm sorry. So the first question we have is, and I think any of you who want to answer these questions can, do you see cellular technology gaining a major market share in the AMI market, or even for lighting controls?
I can answer first. From our perspective, we absolutely see where the market is moving towards that, toward LTE and cellular, as not only for Smart Grid 2.0, but for Smart Grid 1.0 moving forward, just because of the ability to be able to the data acquisition capabilities that you have, and the reduced latency that you have, and the ability to be able to easily go out and deploy in the areas that you need to, when you need to, and not having to manage that infrastructure. It's becoming very attractive to the market in general.
Okay, great. Our next question is, how long does it take to set up a network as a service application?
I'd let Athens speak from their experience, but it can happen very quickly. It can be just a matter of a couple of weeks from the time that we start that we agree to move forward, and to be able to get it set up for the utility.
Yeah,
Okay.
from the utility side, I would say it went really quick on the Verizon GridWide system. We had more problems just getting the meters themselves. That was the big lead time. You finally get the equipment, you can put things in. And I think our antique CIS system was a lot more cumbersome to deal with than trying to upload information to GridWide. We did have some tools that we were able to export reports in a format that was digestible quickly by GridWide. So that really shortcut the process. And I had that running within an hour probably of the request. So, and not very long, I would say probably within 30 to 45 days, we had meters in the field attached to both our system and their system. We had some basis to make an evaluation.
Great, thank you. This question, I didn't know that Verizon offers these types of solutions for the utility industry. How long has Verizon been offering GridWide solution?
We've actually been offering it almost 6 years now to the market, and it's evolved over the years, but it's been about 6 years that we've got a dedicated group that is working on continuing to build out our capabilities and our roadmap for continued participation in the market.
Okay. And what somebody wants to know, what is the duration or how long does the free trial run?
It was 90 days.
Okay. What type of smart meters does Verizon support for the GridWide solution, and who buys those meters?
So the utility would buy the meters. They're directly from their current distributor. Verizon works with both Aclara and Honeywell from a meter perspective.
Okay. What happens if cellular connectivity is not available in part of our geographical footprint?
So in the beginning, we do a very either before you decide to buy the system or and thereafter, we do a very detailed study for you of which endpoints that we're going to be able to reach and which we cannot. There's a certain amount of remediation that we can do, and then we have some additional tools to be able to get to the meters that aren't in the direct coverage that we have. So just like anything, it depends on what the situation is of those specific meters, but we have a lot of tools at our disposal to get those.
Yeah,
We
right.
did find that there were places on our system, there are at least a couple of places where we tried to deploy them where we could not use them. And it was like you saw on the east of, we're on the edge of the mountains and we don't have any of these deep crevasses that we have to creep into, but there are places in our system where we can't get a good signal. It is encouraging that even if you can't get a good cell signal, the data signal for these meters has a priority and it may reach better than the cell phones will.
Okay, great. Looks like we have one more question. If anyone else does have something they want to ask now, please put it in the chat box. And as you see, the contact information is up here. You can always ask questions following the presentation. But if you do have something you want to ask now, please go ahead and put it in the chat box. Here's the last question that I have so far. How secure is an AMI solution with data traversing over the public cellular network and the cloud?
Well, I can answer from Verizon's perspective first. It is absolutely secure. It doesn't transverse the same internet that the general public uses. It's all on private. It's all a private network from end to end, from the meter all the way up through to the utility interface.
We had real concerns about that too, and we were confident after doing a lot of investigation that this really was a separate path. And in fact, we created used one of their other tools to create a hotspot inside of the trucks that was not, had already gone through the filters of our firewalls instead of just being open to the public. I wanted the linemen to have tools in their hands, but not to be able to watch the golf tournament, as an example. So that there are solutions that allow you to be discreet about how you connect to end devices. And we were confident we weren't going to be hacked and have not experienced any problems to that effect either.
Great. Oh, we got another question. Great. Do you have any low voltage complaints when you lower the voltage?
I don't recall that we've had a customer complaint. Now, we have examined and found by report that there was an event that happened that somebody didn't recognize. And that, of course, prompted us to go dig deeper into the system to find out where the real resolution should be. But the feedback so far, even though this is limited, we had to just kind of cherry pick locations versus having an absolute known worst case place to put these meters. We do stop the voltage reduction at the substation or wherever the regulation is when it hits the threshold of, say, 114 volts, and then actually bump it back up to try to pull it back away from 114. So no, we've not had any customer complaints or known issues that were related to running these events.
All right, great. I do not see any other questions. I would like to thank our presenters and Verizon for sharing this really interesting presentation and information with us. As we mentioned at the beginning of the webinar, we will be sending a follow-up email containing a link to the slides and the recording of this presentation. So look for that in the next couple of days. Thanks again for joining us and enjoy the rest of your day. Take care.
Yeah, thanks, Pam.